Today's lesson is called Translating Words into Math, okay? Or basically, since we're doing the entire unit as functions, so we're going to actually turn it into all our math, all the stuff that we're doing into functions actually, okay? Here's our first problem. So here's our first problem. For the following problems, we're going to determine the objective function that we have and the domain, but you're not going to solve them. So you're going to find the non-negative numbers whose sum is 15 such that the product of one and the square of the other is a maximum. Here we go. Here is our solution. So imagine you let x be one of the numbers, right? And you remember that the difference between the numbers is 15. So why not we let the second number be x minus 15. And the reason why we're doing that is we're assuming that the number x is our maximum. So to create the concept of a maximum, we're going to subtract. We're going to have 15 minus x to get that next number. All right, so now let's go and do the computation. So you start with p of x is our function is equal to x times 15 minus x, right? 15 minus x, and we square it based on what they said. So now you end up with x is equal to 225 minus 30x plus x squared. So now we expand and arrange all our stuff properly. So you're ending up with x cubed minus 30x squared plus 225x. So that is p of x. So you would say the objective function is, therefore the objective function is this. And make sure you highlight that for me so I kind of remember what the heck is going on. So now that we've got that, what you have to do next is you have to identify the domain. So the domain calculation, you can show me the work of your domain. So I'll make this nice and big. So I've got d of p is equal to, if you think about it, the numbers have to be non-negative. So the first number x has to be greater than or equal to 0, right? The second number also has to be greater than or equal to 0. So we have 15 minus x is greater than or equal to 0, isn't it? Now, that means the following. So as an aside, you want to remember how to do that. Start with 15 minus x is is greater than or equal to 0. So that means it's non-negative. Then what you have to do is you have to solve for x. You get negative x is less than or equal to 15. Now we divide both sides of our problem by -1, and we're left with x is greater than or equal to 15, because this number here, that sign there should have been -15. So -15 divided by 1 is that. So that is what our domain should be. So that means this thing is really, so that means this is not really this. We want to have x being less than or equal to 15 for the second half of our problem. So now, when we write our final solution for dp, for our domain, so the domain of p is equal to this. You can write using interval notation where you write 0. Is it a square root? No, it's not a square bracket. It's a square bracket. 0 and 15, easy. Or you could write it using set notation, x such that x is less than or equal to 15 but greater than or equal to 0, and x belongs to real numbers. You could do that as well, and you're done. So take a moment and be aware of how that works. If you have questions, ask me about it later. So here is the next problem. A rectangle has two vertices on the x-axis. So I'm going to draw my little x-axis. All right, so now there's my little graph. And then what it says here is I have a circle whose radius is, well, if I'm looking at that circle, that 25 means my radius of the circle is equal to 5 because it's r squared is 25, right? So we have a circle that is 5 and goes down to the x-axis. Okay, so now that I have that, I'm asking to find the dimensions of the largest rectangle that would fit in here. So we kind of have some sort of rectangle that kind of does something like this inside my circle. Okay, now in order to find any point that's on this circle, you're going to have the point, which is x, and then because it's on this corner is on the circle here, this is actually going to be 25 minus x squared. Okay? So it says find the dimensions of the largest rectangle. So yeah, we got to come up with a let statement. And then once we've done that, we have to use some way to maximize the dimensions. So let's do that. So we're going to let p of x, sorry, not p of x, the point x square root of 25 minus x squared be a point on the rectangle and semicircle. And the semicircle. Because basically those two are shared, those points are shared by our value. Now, you'll notice I'm calling this distance from here to here x. And then up at this point here is the square root of 25 minus x squared. So now, here's what we have to do to maximize the area. So you start with a of x is our area. And that means the area of this entire rectangle is actually 2x, isn't it? So the width is 2x, and then we have to multiply by the height of our rectangle, which goes from here to here, and that tells us what our height is. So we say the root of 25 minus x squared. So now we just multiply it through. I guess we could leave it like that. Yeah, you know what? We'll leave it like that. So the domain of the function a is that, right? We need to know what it is. So you know that 25 minus x squared is greater than or equal to 0. All right, so let's say that you guys don't have time to do this on an exam, okay? If I looked just at this thing here, this is a parabola, is it not? Yes? And a parabola when you draw it would look like this. So our parabola is negative x squared plus 25. So our parabola is actually above the x-axis, right? And it's opening down. So the only points that we care about are all the points that are here above the x-axis. These ones are important to us. These other ones, the red ones underneath, we don't need. And they only happen when we find the roots here and here. So just start with 25 minus x squared equals 0 and factor. 0 is equal to 5 minus x. 5 plus x. And so all of we want is all this information in between here. Now, if you actually go to 25, then this whole thing, if you go to 5 for each edge, here's what will happen. You're going to end up with that being 0. Okay? So when you factor this thing, you're going to get x is okay. So this last problem says express the volume of a cube as a function of its base. So there's a cube with all its corners organized, and you know that each side of the cube is x, x, and x, right? There's also a back side of the cube, which I'm not going to really draw because I'm bad at this stuff. And there is your cube. Now, here's what you have to do. Make sure you say your let statement. Let x be the length of a side. Of the base of the thing. So you know that the area of the base of a rectangle is x squared, is it not? So we need to figure out some way to do this. So the area of the base is x squared. So let's call that a. So a is equal to x squared. So now what I'm going to do is I'm going to find x and take the square root of it. Now, normally when we did these things and we square rooted it, we sometimes put a plus or minus. We're not going to do that anymore because you know what? This is a positive length. This is a positive number. There is no negative area. So we're always only going to take the positive. So x is equal to the root of x, root of a. So you know that v is equal to, the v of the cube is equal to x cubed, is it not? Now, if that's the case, this is what you know. X is equal to the root of a. So let's substitute that in. So we have the root of a cubed substituted in for v. So when we do that, we keep solving, right? So let's go. Let's keep going. So you know that that is true. So why don't we change a to a fractional exponent? So this is really a to the exponent 1/2 cubed. Now use power of a power rule. So you have a to the exponent 3/2. And that is what v is. So now we still need to say what the domain of our function is. Here's what you know based on your domain. Your domain of the v function is, if you think about it, the x value has to be bigger than 0 for us to have any length at all, right? But because of that, remember a is equal to x squared, but then we found out that x was the root of a, wasn't it? Right? And the root of a has to be bigger than 0 as well. And so A has to be bigger than 0, doesn't it? So that means the domain of V is just this, 0 to infinity. And we're done. Here's the homework. So your homework is going to be on page 111. You're going to do 1 through 13 odd, 17, 19, and 21. That's it.